So we are very fortunate to have Andrew Cross and Andrew Williamson on our podcast today. So Andrew Cross, would you like to give us a short introduction on who you are and your background?
Yeah, thank you, Johannes. So I'm Andrew Cross. I'm the CTO at Helix. And I've been with the company actually since the year 2000, so almost since the start, aside for having 3 years away having fun in Formula One. So really last 10 years, very much 12 years now in the electrification journey. So looking after some of our major programs and now all of what we call our core technology and R&D activity.
I see. And you also have your colleague who happens to also be called Andrew with you. So Andrew Williamson, who are you?
Hi. Thanks for having me. So I am Andrew Williamson. I'm the Control Systems Manager for Helix. I work in the Inverter Systems department. So I'm responsible for all the application and base software that runs on our inverters that controls our motors. And by way of a background, I was actually a graduate at Integral Powertrain, as we were then, Helix now, and left in 2010, had some time at McLaren Automotive and also Ricardo as well, but been involved in systems and software engineering and control systems for probably the last 15 years of my career.
Excellent. That's quite a lot of very exciting experience you have there, both of you. So, but the topic for today is concentrated around Helix, your current occupation. So we are very eager to learn more about what you are doing, where you are, and how you got there. So maybe some historical perspective. Where did you come from, and where have you ended up as of today?
Yeah, very good. So the journey really for Integral Powertrain, as we were branded then and have been for a long time, was one starting from engineering consultancy. So the 4 directors are still with us now in the business, founded Integral Powertrain in 1998, and that came out of Cosworth Engineering. So then they were engineering typically engines for road vehicles, for different niche applications, things like Escort, Cosworth, Mercedes 190, going back even further. And then so back in 98, business founded really around providing sort of engineering services, but in the more the high tech area, things like downsizing, low carbon technologies, and also some motorsport. So that served the business really well, I think, for pretty much 10 years. But in that time, I think in the mid-2000s, some of the work into low carbon technology and downsizing led us to invent a device called Supergen. And this was a downsizing technology. So it had a centrifugal blower to increase the pressure ratio to get more air into the engine, to allow you to a smaller, lower fuel consumption, lower CO2 engine. But this device needed electric machines, it needed inverters, so electrical hardware, and it needed software. So all those things, we had to develop ourselves. We used, I think on the motor side, we had some suppliers originally and things didn't work out. And we thought, maybe it was bold ambition, but we thought how hard could it be? So we got into it then. And then by 2009, end of 2009, we got our first program for a clean sheet electric motor design for a hybrid application. And that was really where we moved into electrification in a big way in terms of the overall revenue generation in the company. So that's kind of the first 10 years or so. As we moved past 2010, I think 2013, we went into production with that first clean sheet motor and built about 500 of those units. And then pretty soon after, we got into what we call ultra premium motorsport. So very, very top level motorsport. Again, some really challenging applications. The hybrid applications are very high G loads and very high temperatures, things like this. And so that was very exciting and established us as a company that makes what are the highest power density motors in the world, for sure, and certainly the highest continuous power density motor in the world. Moving forward, mid 2010s, we've now got multiple programs, some hybrid electric vehicle, but also a lot of battery electric vehicle programs. 2018, then you probably remember the Volkswagen IDR Pikes Peak record. So kind of in and around the time of Dieselgate, then I think Volkswagen Motorsport had a push around the ID brand, and the pinnacle of that then was this fantastic racing car, and we developed the motors and inverters in about 8 months to put that car up the hill in 2018, and that was great because we beat the electric record by over a minute, but also the outright record by 16.5 seconds. So yeah, real landmark then for electric vehicles, because it was a time when in open competition, the gasoline powered vehicle was considered the technology, when this was a case where what was milk float technology is now clearly demonstrated as better, and could be better than the internal combustion engine.
And I've seen the video from the Pikes Peak. It's incredibly amazing. It looks like an RC car when you see it from the air.
Yeah, it looks kind of sped up, doesn't it?
This long story that you're outlining, starting with combustion engines, now more and more fully electric. Surely that is a really big shift also in technology and engineering. Can you comment a bit on how you have been able to cope with that, transforming your skills and knowledge and the way you operate to work with what I would see as completely different technologies, even if it's still applied in automotive?
Yeah, very, very good question. I think one thing to say on the technology side is, whilst the electric machine has been around an awful long time, it's things around the electronics hardware, so the power electronics, as well as the controls, that make certain things in the electric machine possible that weren't ever possible before. So kind of not much new in the way the physics of the electric motor are working, but the things that are now enabled by the electronic side are what's exciting, and that's what's moved really quickly. And I guess in terms of our story, part of the reason for getting into high power, high voltage inverters was to be able to test our machines, because we could see the requirements, and we were getting the requirements for extremely high power densities, and they only become possible at quite high electrical frequencies. So to support those electrical frequencies, you need very fast switches and you need very fast processors. So this is where all our hardware and software come into play as well.
And to develop that level of knowledge internally, can you comment a bit on how you have been able to achieve that? So I'm sure you need a different flavor of engineers to be able to achieve.
Yeah, I mean, certainly on the electromagnetic side, so Maxwell's equations are things that the internal combustion engineer didn't need, but then there's an awful lot that is transferable. So the way of engineering complex systems and the thermal management heat transfer problems, they're all highly transferable. And the mechanical problems, we're talking rotors in some of our machines that have surface speeds around about Mach 0.8. So that whilst they're simple devices compared to an internal combustion engine, some of the forces involved are fairly extreme. So a lot of it becomes transferable, and I guess the level of detail you get into in something like a combustion system, compares to the level of detail you get into in high frequency electric machines and managing losses at these very high frequencies, which frankly had never been tested before.
And I guess that would also require maybe a more diverse set of competencies across your teams. So how does that affect, or what kind of challenges does that make in terms of collaborating between people who are experts in electrical and electronic systems, in mechanical, in software? Do you have any? What are the experiences you have made from that?
Yeah, I guess being good with metaphor is one aspect. To one man's flywheel is another person's inductor, and one person's spring is another person's capacitor. So there are things like that. I think that, if you like, the softer side of these things is important as well. So the building of teams that work well together is a big part. Getting it to a stage where people really want to collaborate and push in the same direction is a big part of that. So the cultural side of the business and organisation.
And would you say that you have changed the way of working as part of this transition? Do you work differently today compared to 10 years ago or 15 years ago?
Yeah, I'd say so. I mean, increasingly, we're taking a more model-based systems engineering approach. That comes from a few directions. So certainly the automotive advanced product quality planning, APQP processes. So that V curve, requirements cascading down and then building back up the other side. So there's much more of that today, and in fact we're now related to that. We recently, I think last week, got our IATF 16949 accreditation, which is the automotive sort of production quality standard. And I think probably, I don't know, my colleague Andy might like to comment on that question as well.
I think so. Things are much more driven, certainly on the inverter system side, by some of the standards. So it's not legislation, but kind of pseudo legislation like ISO 26262. So the functional safety requirements for anything with electronics and software in it, and that standard follows a V cycle. There's a typical diagram that shows the V within the V. So there's a system level V, and then there are two internal Vs for hardware and software. So from that point of view, it's unavoidable to develop products really for the automotive market without following systems engineering processes, because you won't meet the requirements and the work products of ISO 26262. For an example, there are others now. So the cybersecurity ISO 21434 as well, follows the same V curve. So I think the way of, I've been away from the business for the sort of the formative period that Andy mentions, from sort of 2010 onwards, I suppose, in terms of the electrification journey. But certainly, having come back into the business now, it's much more structured in the approach. Things are much more kind of requirements driven, defining what a customer wants from a project, and how we make sure that we achieve those requirements. So certainly that, in comparison to how we used to work on a consultancy basis, is very different. So the difference between a product business and a consultancy business is clearly very, very different. And you have to be kind of systems engineering focused if you're developing products, for sure, I would say.
Absolutely. And some of the things you have highlighted, this maybe more external and maybe more regulatory needs or requirements. If you look into more improvements or achievements more from an internal point of view, what are the areas that you would be focusing on in terms of what and how do you want to improve in terms of, I don't know, speed, quality, cost, other aspects that kind of improve your competitiveness?
It's certainly in terms of our growth. We're now looking much more multi-sector, so various new sectors electrifying. But if we take automotive, it still remains a big focus for us as a business, and there we've got an awful lot of work already in sort of the hypercar and motorsport space. So to grow, we need to grow in kind of the layer below that. So what we call the high premium space. So this might be vehicles in the sort of £150,000, £250,000 sort of price point, and that market is maybe 150 times larger than that top tier hypercar market. So that's a space for growth. But to achieve growth in that area, there's a lot more cost pressure. So the areas we are improving on, probably spent the last most of my last 3 years working on, is about cost of bill of materials and cost of assembly. So we have a lot of vertical integration in the business, and we make a lot of what we do in house. We wind our teeth, we build the rotors, that sort of thing. But all that said, with all that level of vertical integration, we're now talking at sort of 8 to 10 hour build times for what might be a 300 kilowatt motor that's this sort of size. That's one of the key areas for improvement. So it's bill of materials cost and time associated with assembly. So they're very much key drivers.
Mm-hmm. And since you have this legacy, I'm sure you have been through several generations of IT tools within CAD, within simulation, within PLM. What are the benefits that you experience or see from this development? If you look a few years back and until today with more modern and integrated tools.
Yeah, so I think as we've grown and more programs, more products, the importance of consolidating systems, having a single source of truth, avoiding any sort of non-value add tasks, which not only is waste in the business, but also opportunity for error. Those sorts of things have been really important. So an example of that is we had a separate concerns system to manage concerns, and now we have an issues system that sits inside the 3DX environment. So that means when we raise an issue against any particular product during its development cycle, then we can attach that to real 3DX entities. So when they get fixed, or when a drawing gets released, it automatically is resolving that issue, and we can track things that way. So I think it's those sorts of things. It's consolidation of systems, having the minimum number of business nodes, as it were, that does the job.
And do you see any concrete or measurable benefits from that in your kind of daily operation?
Yeah, I mean, we do. We certainly track the things like how much time goes into making an engineering change, and so we can measure, how we've improved the systems there to overall improve the business.
That's great. And if you look forward, so you already mentioned you have a fast-growing business. You're moving into new domains, working with new industries. What are the changes you expect moving forward, and what new challenges do you see in front of you?
I think sustainability, is a key agenda point, if you like. Where we are with our products in use, they provide massive benefits. So most of the CO2 or CO2 equivalent benefit comes from just using the product. But we also have to, be mindful and work towards sustainability in the manufacture and end of life. So here, ISO 14001 is something we'll be doing over the next 12 months. And the sustainability of the product itself, the things we can do, that's becoming more and more important. Something we can do, and I've been doing recently, is with our rotor architecture, because we have cooling in the rotor, we can specify magnets that are free of heavy rare earths. So that's something that will feature on all of our volume automotive products, and that we can say will be HREE free, the heavy rare earth free. So that's a major benefit in terms of really global supply chain, but also the sustainability piece and what raw materials are required to go into the product.
And what are the main drivers for you to improve on those areas? Is that mainly coming from your customers, or how do you see that the kind of push for more sustainable products?
Yeah, it's coming internally, but also from customers. Certainly, it varies, I would say, globally, but I think particularly in the Nordics, that's an area where there's a very strong sustainability push. I think they kind of lead that area.
Yeah, so I'm based in Oslo myself, so I can confirm. EVs are outselling all other forms of drivetrains. Yeah. I think it's up to 85%.
Yeah, wow.
These days. Great. And within this sustainability topic, are you also looking into software tools to support you on that in analyzing your products and predicting their kind of environmental footprint, if you like?
Not at the moment in specific software tools. We follow the sort of life cycle assessment type process for the products, so we can do that based on sort of database numbers for the materials and the amounts of materials we use. So that's the approach. That's the approach currently.
We also touched a bit on the topic of model-based engineering and model-based ways of working. Could you elaborate a bit on how you see that and the potential for developing such methodologies moving forward?
Yeah, definitely. We've always been a kind of highly model-based and first principles led company, and I think the key there for us, and maybe our strategy, which might differentiate us a little bit, is in having kind of the right level of model, so you can the engineer can really understand how his inputs are influencing the output. So a clarity and a speed of turnaround in some of the simulation tools or model tools there is important within the business, and also how they are common. So how we flow from what might be a very early concept simulation into like a time marching to time varying type simulation, and then into models within inverter software that are actually live running in the products. So it's ensuring that those things flow down, so that we're keeping that single source of truth whilst adding layers of complexity. And I think the same can be said in how we design machines as well. So we can take a set of parameters that define the high-level concept, but then flow down into what we call application tools, which then add the detail of, well, how is this going to be manufactured? So I understand, how long the stager is going to be. It's going to be 100 millimeters long. Well, what are the tolerances on that, and how do the manufacturing processes influence that? So it's how those things link together and cascade, if you like.
I think I can just jump in. I think the future sort of direction of travel there is around the digital engineering piece. So Andy sort of alluded to it already, but effectively it's having an end-to-end kind of model-based description of your system where you try and maintain a common set of interfaces between each key element of the system, but you can have different models with different levels of granularity and detail and then execution speed that you can drop in place. So basically, if you just wanted to do a vehicle level simulation of your complete powertrain over something like, a real world drive cycle, well, you don't need the absolute nth detail in each particular component. But if you were doing some cooling analysis, say on a particular part of the system, then you would drop in the very, very detailed model, because from that point of view, you'd want to really know what the heat rejection really was and what the real currents were and everything else like that. So I think that's really the ultimate objective of trying to characterize the entire system in a model-based way. And then also the layer underneath that as well is having the requirements defined as well, that make sure that you can use that system then to validate your system, and you have that end-to-end traceability. That's certainly my view of the journey and the pathway, if you like. I think there's a way to go, but that's really the way. And I think people have proved it. I remember hearing that Ford had deleted all of their A-sample hardware for engines. So they were so confident in their 1D simulation, they just said, well, we don't need to build any A-sample hardware now. We're going to base everything on the 1D simulation and make the design for B-sample without ever running a single engine on a dyno. Yeah. And from an environmental perspective, you have to say, well, that's fantastic, because how much fuel was saved not running all those things on the dyno. So there's, the benefits in terms of product quality and the environmental impacts are absolutely enormous if you can really get it right.
Absolutely. And one thing I'm also curious about is that, knowing that some of my colleagues are working closely with you guys for many years, what are your expectations from a partner to providing software tools and services, and in what way can we help you moving forward to meet some of these challenges that you have outlined in this conversation?
Yeah, I think one aspect is sometimes it's bridging the gap between a well-developed piece of software that has a high degree of functionality with data interfaces that we might have in the company that that don't necessarily match up. So, but it's really important, I think, and Andy talked about this as well, about how those things are interfaced, because there has to be a common language, and you have to be able to interface. Otherwise, you're back to manual intervention and wasted effort. So it's I think a lot of the time it's bridging that gap between maybe bigger products and configured to the requirements of our business.
I see. But I think it has been really interesting to listen to what you have explained about where your journey so far, where you are today. If I have one last question, that would be, where is Helix in 10 years from now? What kind of company are you?
I think 10 years from now, I won't share all of our growth plans, but we have a growth plan going out to close to 2030. So it's significant growth, bit more than 30% CAGR, and a continued sector diversification, and it's applying our scalable products. We spent a lot of time, because of the diversity of applications that we see, trying to bake as much scalability as we can in the products. But then the product is assembled, is procured, is made, is assembled in very much the same way. It could be something from a marine outboard that needs to run 200 kilowatts continuous, or it could be a motor for an aircraft, for eVTOL, or it could be a traction motor for an electric car. And there's a lot of commonality that threads through those things. So it's maintaining that scalable core technology and continually evolving it. Inverter products will be a bigger part of the business going forward. Very much, more and more products, new products. So there's growth in the electronics area, expansion, some new products there, and there's things like series hybrid technologies where passenger electric cars. We think battery electric vehicle is the technology, will be absolutely the incumbent technology. Don't see a credible competitor to that, but there are various other sectors and applications, commercial vehicle and off highway, and some other sectors where the energy density of the battery won't quite make it. So here we think some series hybrid is useful. So coupling to different kinds of engines, be that gas turbine or internal combustion engine. So some of that will be fun and feature in the business going forward as well.
And from this other industries or applications besides automotive, which one do you believe the most in? Where do you think you see the biggest growth potential? Is it on sea or in the air or other applications?
Yeah, good question. They're all starting to happen. Marine is an area where we thought that this could happen quite quickly, and it is doing. So the sort of barriers to entry, if you like, are quite low in marine. So the time to market can be quite low because certification, legislative requirements are on the small side, particularly as you compare to aerospace. So that's an area where things are starting to happen quickly, and we have a few programs active now in marine. Aerospace we've been talking about for a long time and talking to people for an awful long time, but that's also starting to happen now, and that could be pretty big. There's a lot of value in traveling by air, and obviously it's a pretty disruptive space. So I think that comes in the more the significant revenues come in the more sort of 5 to 10 year horizon on that. And then commercial vehicle and off highway, there's some really strong business cases there to transfer to all electric or hybrid electric vehicles. So there'll be very sort of simple commercial decisions at the sort of OEM level, and it will happen quickly, and some of that's driven by legislation on that side as well. So I think that'll happen really quickly, and with the configurability, the scalability of our products and high continuous power density, that's an area where there's a really good fit. So I think those, if you like, 3-4 areas are ones that will be pretty exciting for us.
It seems that you're pretty well positioned and at the forefront of a very fast evolving technology that is highly relevant for many industries. So really exciting times, and I think it remains to see where we are in 10 years, but I'm sure it's not as exciting.
I think so, yeah. Definitely exciting where we are today.
Absolutely. So thanks a lot, both of you. Super interesting to learn more about Helix and what you are doing. Hope we can help you and support you on your continued journey of success. Again, thanks a lot.
Likewise. Yeah, thanks, Johannes.
Thank you very much.